Hello everyone. Today in this series of videos, I'm going to explain some techniques to do forecasting when there is a seasonal pattern in the data. Then I will talk about associative models as another technique for forecasting. Then I will explain how to evaluate the performance of techniques that we have used to forecasting, and then I will talk about how to monitor the forecasts. Okay, so let's first start with techniques for seasonality. There are two types of models that we use for seasonality. Additive models and multiplicative models. In the additive model, seasonality is expressed as a quantity which is added to the series average in order to incorporate seasonality. Also, we have multiplicative models that they consider seasonality as a proportion of the average, which is then multiplied by the average of the time series that we have. So in these two types of models, we need to first calculate seasonality and then add seasonality to the forecast that we make. The general process is to first find the seasonal relative, then to deseasonalize the input data, and after doing the forecast using the deseasonalized data, we need to reseasonalize the forecast. Here in this slide, you can see the process that we should do to make a forecast when there is a seasonal pattern in the data. First, we need to compute the seasonal relatives, and then we should deseasonalize the demand data. Here, these demand data are the input data that we are using. We should take the seasonal factor after from them, and remain data should be used to do forecasting. So we should in the next step, we should fit a model to do forecasting, and then the forecasted data should be reseasonalized. So this is the process that we should do. Let's see some examples to make it more clear. Here in this example, a furniture manufacturer wants to predict quarterly demand for a certain love seat for quarters 15 and 16, which happen to be the second and third quarters of a particular year. The series has both trend and seasonality, so we need to do find some techniques for seasonality and then incorporate them in our model. Quarter relatives or seasonal factors are Q1, Q2, Q3, and Q4, and you see their values. For example, for Q1, this 1.2 shows that in the first quarter, the demand will be 20% higher than the average. Or as another example, Q3 shows that in the third quarter, the demand will decrease by 25%. Okay, the trend proportion of deseasonalized demand data is projected using the equation FT equal to 124 plus 7.5T, where T is the index of the quarter and FT is the estimate of the trend component of demand in quarter T, using the linear trend method. So we need to use the information to predict demand for quarters 15 and 16. Okay, so quarters 15 and 16 are second and third quarters. So we need to use Q2 and Q3 as the seasonal factors for these two quarters. Here in this example, we have deseasonalized data first. We have first calculated the seasonal factors. Q1 to Q4 are the seasonal relatives, and then we deseasonalize the data, and we have used a linear trend model, and here is the line equation that we use for forecasting the date, the deseasonalized data. Then the forecasted data should be used to for reseasonalizing the data. It means that we need to use this model, this linear trend model, to forecast the data, and then add the relative seasonal relative to the forecast. So here the trend values at t equal to 15 and 16 are provided for you in these two equations. F15 will be equal to 236.5. We have used the line equation provided for you here. And for period 16, the 16th quarter, the demand is forecasted 244. So it means that now we have the forecast and we need to add the seasonal relative to them. For the quarter 15 and 16, we need to use Q2 and Q3 because they happen to be in the second and third quarter. So we should use Q2 for F15 and Q3 for F16. So 263.5 should be multiplied by 1.1, which is Q2. And for period 16, the forecast considering seasonality will be equal to 244 times 0.75, which is equal to 183. And this is the final forecast using the seasonal relatives. Right, let's go to Excel and do this example, solve this example on Excel as well. Let's first start talking about how to find the seasonal relatives, and then I'll come back to the Excel. Okay, how to calculate this seasonal relatives. There is a method named CMA, or Centered Moving Average. In this method, the computations are similar to those for a moving average forecast, but the values are not projected as forecasts. Instead, they are positioned in the middle of the set of periods used to compute the moving average. And the implication is that the CMA, or centered moving average method, is most representative of the middle point of the repeating period. So in this method, we should, in this step 1, choose our period and then calculate the moving average. And then we can use the moving average of the calculated period as the seasonal relatives. So by considering this CMA method, let's now go to the Excel and solve the example using it. So here you can see that we have the data about different days in a week. So we can consider 1 week as our time horizon. So we should select 7 days of week, and we should calculate their average, and their average will be considered for the middle day, and the middle day of this 7 day will be Friday here.